Today we're going to talk about adding integers, but before we get to some examples, we have to learn about one special property of addition, and that is the inverse property of addition. The inverse property of addition says that if I add two opposites, let's say 2 plus negative 2, my answer will always be 0. And this makes sense if we think about what these numbers mean. Positive 2 can represent having $2, and negative 2 can represent losing $2. So if I start with $2 and then I lose $2, I should have $0 left. The same works the other way. If I start with negative 7 and I add 7, I will always get 0. This property holds true for all numbers, and the general form of it we can write a plus negative a equals 0. It doesn't matter what a is. If we take a number and we add the opposite of that number, we will always get 0. This property is going to come in really handy with what we're going to do today. The way that we're going to add integers today is called the counter method. The counter method means that for each number we have, we can represent that number with that many counters. So the number 3 we can represent with 3 circles. Now, because 3 is positive, we're going to mark each of these circles with the plus sign. Hopefully your plus signs look nicer than mine do. So to represent the number 3, we have 1, 2, 3 positive counters. If we wanted to represent the number 11, we would draw 11 positive counters. And we can do the same thing with negatives. If I want to represent negative 5, I'm going to need 1, 2, 3, 4, 5 counters. But because this number is negative, each of these counters is going to be negative. So we have a negative 5, we have negative 1, negative 2, negative 3, negative 4, negative 5. All right, let's take a look at a couple examples. Let's say we're trying to do 3 plus 4. We know what that is, right? But let's get a little bit of practice with these counters. Positive 3 gives us 1, 2, 3 positive counters, and 4 gives us 1, 2, 3, 4 positive counters. Now, if I count my total here, I have 1, 2, 3, 4, 5, 6, 7 counters. So my answer, and they're all positive, so my answer is positive 7. Now, you're probably thinking, why did we have to do those counters? I know 3 plus 4 is 7. The reason we use them is because it gets trickier when we start involving negative numbers. So let's take a look at a basic negative number example. Let's try negative 2 plus negative 6. Okay, what is negative 2 plus negative 6? To represent negative 2, we're going to use 2 negative counters. To represent negative 6, I'm going to use 1, 2, 3, 4, 5, 6 negative counters. Now, if I look at all the counters I have together, I have 1, 2, both negative, 3, 4, 5, 6, 7, 8. 8 negative counters, so my answer is negative 8, right? If you owe one friend $2 and you owe another friend $6, you owe $8 altogether. All right, those two examples are pretty straightforward. Let's see what happens when we mix it up and we add a positive number with a negative number. 5 plus negative 7. What is that going to give us? To do this, we can draw our counters. Positive 5 is going to give us 1, 2, 3, 4, 5 positive counters. Positive 1, positive 2, positive 3, positive 4, positive 5. And negative 7 is going to give us 1, 2, 3, 4, 5, 6, 7 negative counters. Negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. So now we need to think back to the property we learned about at the very beginning, the inverse property of addition. If we take a number and add its opposite, we will get 0. So if I take this counter here, which represents positive 1, and I add it to this counter here, which represents negative 1, that gives us 0. 1 plus negative 1 is 0. Those counters cancel each other out. 1 plus negative 1 is 0. 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 And we're left with these two counters here. Negative 1, negative 2. So that's our final answer. Negative 2. Let's try one more example, except this time let's start with a negative number. So let's look at negative 4 plus 8. We'll pick a bigger number here. So negative 4 can represent that 1, 2, 3, 4 negative counters, negative 1, negative 2, negative 3, negative 4. And 8, we are going to have 8 positive counters. I hate writing plus signs on this thing. There's positive 4, positive 5, positive 6, positive 7, positive 8. Now the same thing is going to happen here. Each negative is going to cancel out with a matching positive if there is one. Negative 1 plus positive 1 is 0. Negative 1 plus 1 is 0. Negative 1 plus 1 is 0. Negative 1 plus 1 is 0. And our answer is what's left. We have 4 positive counters. 1, 2, 3, 4. So our answer is positive 4.